Okay. So, converting fractions to decimals is where we're going to start. So, if I have a fraction, how do I turn it to a decimal? So, to convert fractions to decimals, we are going to divide the numerator by the denominator. So this brings back some long division that some of you may or may not remember how to do. So the denominator, it goes on the outside. The numerator goes on the inside of your division. And long division, we divide, multiply, subtract, bring down. Right, that's our process for long division. So 4 goes into 9 how many times? Twice. 2 times 4 is 8. We're going to put it right here. So we divided, we multiplied, we are going to subtract here, and then we're going to bring down that 2. Okay? So then 4 goes into 12 how many times? 3. Oh, did I mean to do this? I think I meant to make it like, let's change this, because as you can see, we're not even getting a decimal here. Let's make that 94. Okay, so let's change that to 94. I need to work out the problems that I'm doing. All right, how many times does 4 go into 14? Still 3, right? So I've divided. I need to multiply. 3 times 4 is 12. Subtract. I will get 2. And then I've got a remainder here. So if I were doing mixed numbers, I could just say 23 and 2/4. Sometimes you might want to do that. That's 23 1/2, and you can really easily change that to a decimal. But sometimes it doesn't work out so easily there. So let's say that we're just wanting to do a decimal here. Can I add 0.0 to the end of this number right here? Does it change anything? It does not, right? So if I put a 0.0, now I could bring down that 0. I just need to make sure that I've got a decimal place right here. And so I can continue that dividing process, and I can add as many zeros as I want at the end of a number, because adding a 0.0000000 does not change the value. So how many times does 4 go into 20? 5. 5 times 4 is 20. We subtract. We get 0. We don't have anything else to bring down, so there's our answer. So when we're converting our fractions to decimals, we may need to add that 0.0 on the end so that we can get our decimal. Okay, questions? All right. Wait, did I have 2? No, I just have 1. Okay, I'm converting decimals to fractions. And I will let us use some mixed numbers here. We could convert it to improper fractions if we want. But to convert decimals to fractions, we'll put the decimal part of the fraction over 10, 100, 1,000, etc., depending on the place value. I mean to put there. know what I meant to put in this blank. I'm sure I had something good in mind whenever I made these notes. And that kind of works. I don't know what I meant to put there, but it makes sense just to stop here and say place value. I'm losing my mind. So if we are looking at 1.2, our whole number is 1. And then we would have 2 over, what do I use here? 10. Okay? And then 2 over 10 will reduce, what is it? 1/5. So that would give us our mixed number. If you need, we already worked on mixed numbers to improper fractions. If you need an improper fraction, you could do what we did before, 1 times 5. So give us 5, add 1. We could also say this is 6/5. But the mixed number is okay. Okay. So if we look at example 3, whole number is 52. And I've got 0.05. What would I put that over? I've got I could write 05 like that if I want. Does that look like I know what I'm doing? It does not. Do I need that 0 in front? No, let's get rid of that so we look a little smarter. What do I write it over? 100. Good. Okay, because we got 2 places, so we'll have 2 zeros here. And what does that reduce to? 1 over 20. Yes. So I got 52 and 1/20. If you need to, for some reason, have an improper fraction there, you can turn it into that, but we're just going to stick here. Okay? All right, I got 123 here. What should I put that over? 1,000. Okay, because we got 3 decimal places, which means we'll have 3 zeros on the number that goes at the bottom. And I don't think it'll reduce. I'm pretty sure it will not. There. I think I checked that one in the calculator. I don't think it does. Okay. All right, example 5. I have 8. And then, Riley, what would the fraction part of it be? Not 1,000, 100. So we'll do 74 over 100. Aiden? 37 over 50. So if I divide top and bottom by 2, Aiden's telling me I get 37 on the top. I think that seems right. And then 50 on the bottom. I don't think it will reduce any more than that. Now, it is much more likely that you got to go from decimal to fraction if you've got something easy like example 2 than that you would go from 8.74 to a fraction. But we need to know how to do it either way. All right, questions? Okay, adding and subtracting decimals, we need to make sure the decimals are lined up. You guys may know this since we're talking about decimals. So you may know this, but I am a math teacher and did not know this until 2 years ago. Do you know that there are countries that would write this problem right here like this? There are many countries that use a comma instead of a decimal point. And they use a decimal point like we use a comma.
Okay, that's disturbing.
Yeah. I was a couple years ago, I was looking for videos in Spanish for a couple of my students that had just gotten here and didn't speak a lot of English. And most, like Mexico uses a decimal point like we do, I believe. But in Spain, they use the comma. So some of the videos that I was looking at were people from Spain that had the weird sound whenever they spoke Spanish. And so I knew it was Spain because of the accent, but they kept writing this with the comma, and I couldn't figure out what they were doing for a little bit, and then I realized that lots of European nations use the comma. Most, like Mexico and most Central American and South American countries use the decimal, but I think it was. But a lot of European countries use the comma instead, which is crazy. Never knew that. How did I not know that being a math teacher? Mm-hmm. Huh? What?
Depends on if they use it in grammar. If they use it in
I don't
grammar,
think.
then
I think it's pretty split. I think certainly measuring something in pounds and feet and all of that, we're definitely the weird ones on that one. But whenever I was looking this up, it seemed more split. Like they're more like half and half. Like there are a lot of countries that use a decimal point. So we're certainly not the only ones, or one of a very few, but there are lots of countries that do it both ways. So I can't remember where each one of them fell necessarily, but this right here, I hate, just so you know. I do not like that they use a comma instead of a decimal point. It bothers me to see 8,95 right there. Yeah, if they wrote 8,000.25, they would write it this way.
But wouldn't there also be another decimal where that comma is?
No, they use the comma like we use the decimal, and they use the decimal like we use the comma. So, we would write it this way, 8,000.25. They switch the way they use those. Yeah. It may not bother some of you as bad as it bothers me, but this drives me crazy. It's against everything I've grown up understanding. Yeah. It does need to be changed. And in fact, actually, thank you for pointing that out, because this calendar I put up here because I wanted it to be my birthday calendar. So, sorry if your birthday was in August. If I have August birthday, don't Carla happy birthday. So, I've got you guys all year. Sorry if you got a summer birthday too. I just want to remind myself it's your birthday. It's your birthday. So, it's not like you want to get your present or anything. Because I can't afford that for 60 kids. But, find your birthday on this calendar and write like Caitlin's birthday. Yeah, so pass that around and put your birthday on it. It reminds you you've survived one more year. Yeah. I'm not sure I'm bragging about age now, but when I get old, there's a certain point I'm going to start bragging about my age. Probably like 80 plus. Because not everybody makes it there. So, if I'm like 92, I'm going to be telling everybody that I'm 92. I mean, you're so old at that point. Yeah. yeah, we're going, I mean, if you're 100, I'm not going to be around to help you celebrate. But, but I would have a big party if I made it that far. So, now, whenever you're something like that. It fluctuates who is the oldest, from time to time, but they're usually in their, like, 1-teens sometime. I don't know who, yeah. That's crazy to live that long. Yeah.
There's no point living that long. You're so like, you can't move. Yeah.
Well, I mean,
You also have extreme Alzheimer's at that point. Like, you forget years.
not necessarily, but, yeah, I mean, there's probably not too many 119. But if you live to be 119, you're probably still in, like, decent shape at 100. Whereas a lot of people at 100 would be falling apart. So, I mean, maybe. I definitely wouldn't want to live like the last 20 years of my life just kind of laying around. But usually those old people that they're super duper old, they're at least sitting in a wheelchair and maybe talking a little bit whenever they're on TV.
Well, the oldest person who could like run more than a mile, she's like 90.
Wow.
You're going to have a cardiac arrest.
I don't even know if I can meet that description running more than a mile. I could, but it wouldn't be good. Okay. Alright. So, let's subtract some decimals. First number always has to be on top. Second has to be on bottom. Unless, I may actually throw one more example in here. We'll worry about that unless in a minute. Now, in this case, you have to make sure you line up those decimals. So what am I going to do? The first number shorter. Good job. But can I do 0 minus 6? No, I must borrow. So that'll be 4. 4 minus 0 is 4. 9 minus 4 is 5. Keep that decimal lined up there. And we get 5.544. Let me add in, this is going to be example 6.5 right here. Let me add in one more example. What about if I have something like 2.83 minus 4.92? Okay? When I'm subtracting this by hand, which number has to go on top? The bigger number has to go on top for you to do this by hand. But what do we know about our answer that we're going to get here? It's got to be negative because this is actually negative here. So to figure it out, we're going to do 4.92 minus 2.83. Okay, so I'd have to borrow here. 12 minus 3 would give us 9. 8 minus 8 would give us 0. 4 minus 2 would give us 2. But because 4.92 is bigger than 2.83, I would have to give the answer negative 2.09. Okay, we are right here. Okay, most times students are good with adding and subtracting. Multiplying decimals. Students have usually forgotten how to multiply decimals. It's really not that difficult. You're just going to ignore the decimals completely while you're multiplying. And then you'll count the number of decimal places in both numbers. That's the number of decimal places in your answer. So I have 2 decimal places here and 1 here. So my answer is going to have 3 decimal places in it. Okay? So I'm just going to do 213 times 56. You can put the decimal points in those numbers if you want, but you're going to ignore them. So if you leave them out, that's fine too. Okay? So 6 times 3 is going to be 18. We'll carry the 1. 6 times 1 is 6. Add the 1, you get 7. 6 times 2 is 12. Now I've got to go back and do the same thing with the 5, but what have I got to do first? I need to put a 0, or some people put like a line or something to show that they're going to start underneath that 7. So you got that, because this is 50 instead of actually being 5, you got to put that placeholder 0 right there. 5 times 3, 15. 5 times 1 is 5. Add that 1, you get a 6. 5 times 2 is 10. We're going to add those together. Ignore decimal places. Don't try to put decimal places in these right here. So 8, 12, carry your 1, 9, 1, 1. Quit disrupting. I said quit disrupting my class and go on to where you're supposed to be, boy. That youngin'. What was that? Okay. Alright, 1, 2, 3 decimal places. So 1, 2, 3. We'll get 11.928. And so that will be our answer.
How is it?
So we're going to count the number of decimal places in our original numbers. So I've got 1, 2, 3 decimal places in our original numbers. So I'll have 3 decimal places in our final answer.
Oh.
Okay, questions? All right. We got, last one is dividing, but there's 2 cases we're going to look at here. So let's look at the first case where the decimal is in the numerator. So if the decimal is in the numerator, we'll divide like normal, keep the decimal place where it is. Add extra zeros if necessary. So we do 7.24 if we're dividing this by 5. We are just going to divide like we normally would. We're going to have that decimal place right there that stays in that spot. So, how many times does 5 go into 7? 1. 1 times 5 is 5. Subtract. We get 2. Bring down. We've got 22. How many times does 5 go into 22? 4. 4 times 5 is 20. Subtract, we'll get 2. Bring down. Okay. How many times does 5 go into 24? 4 times again. 4 times 5 is 20. Subtract, we get 4. 5 won't go into 4. We got to add an extra 0 here and bring that down. How many times does 5 go into 40? 8. That goes evenly because 8 times 5 is 40. Subtract, you get 0. So you will be done. So 7.24 divided by 5 is 1.448. Sometimes you'll get stuck in a loop, right? So you keep getting that same number and over and over and over. Like, for example, we're doing 4 divided by 3. We get stuck in a loop where we're getting 3, 3, 3, 3 over again. So if you start getting stuck in a loop, you know it's just a repeating decimal for those. So you can just, what's the symbol we use for a repeating decimal? We put the line over top. So like if we were doing 1/3, we could write that as 0.3 with the line over top of it. So if you notice that you are in a loop, you just put that line over top. All right, last one here before we do our assignment, I think. Is this the last one? Yeah. So the decimal in the denominator. We're going to move the decimal to the end of the number and then move the decimal of the numerator the same number of places. So I'm going to start off with this problem 1.2, and we're dividing 250. Okay, so doing this with decimals is just difficult and not going to work out very easily. So I can just move this decimal to the end, which is just one place, which means if I do that here, I also need to take this decimal, it doesn't have one, so it's at the end, and move it one place, which means I'm going to have to put a 0 right here. So rather than doing 250 divided by 1.2, I'm actually going to do 2,500 divided by 12, but it will give me the same answer. So how many times does 12 go into 25? 2. 2 times 12 is going to give me 24. Subtract, we'll get 1. Bring down. Okay, how many times does 12 go into 10? 0. So I'm going to have a 0 right here. 0 times 12 is 0. Subtract, we get 10. Bring this 0 down. 100. How many times? 8. So we've got 8 times 12. It's going to be 96. That's going to give us 4. Now, our decimal, we moved it to here, so we need to make sure it's in our answer. We need to add another 0, bring it down. How many times does 12 go into 40? 3. And then we'll get 36, subtract 4. Uh-oh, yeah. This is happening again, right? So I'd get another 3, and then it's just going to keep on going, so I can just put a bar over that showing that that's repeating. So I'd say 208.3, the bar over top of it. Okay, questions? All right, so